All right, guys, we're into chapter 10 now, section 1, dealing with square root functions. So previously you graphed linear and quadratic functions, and now we're going to graph and analyze dilations of radical functions and graph and analyze reflections and translations of radical functions. So just a couple things we're going to be talking about as far as vocabulary is concerned is square root function, radical function, and something called the radicand. So let's first talk about dilations of radical functions. A square root function contains a square root of a variable. Square root functions are a type of radical functions because they have the little square root thing. And if you look at it and squint your eyes and use your imagination a little bit, the radical looks almost like a lowercase r, okay? So that's kind of where that idea came from. So this symbol is called the radical, and we've talked about cube roots, fourth roots, nth roots, and so forth and so on. Those are all radical functions. The expression under the radical sign, like what goes in here, is called the radicand. For a square root to be a real number, the radicand cannot be negative. Values that make the radicand negative are not included in the domain. So the parent function is the square root of x. It looks like this. And the graph is a curve. It's not a straight line. It's pretty much a sideways parabola, but just the top half of it. So if you have a parabola like this, well, if you drew it sideways like this and just took the top half of it, that's what the square root function is. The domain of square root functions, the x values that you're allowed to use, are any numbers greater than or equal to 0, because remember, you can't take the square root of a negative. And the range is the same thing, y greater than or equal to 0. Okay, so what we want to do is graph two square roots of x and state its domain and range. Well, first thing you got to do is make a table of values. And again, we're just going to use non-negative numbers, so like 0 and positives. And we'll use 0, 0.5, 1, 2, 3, and 4. And if you take the square root of those, what you can do is just go turn your calculator on. There's two ways you can do this. You can hit second square root, put in 0, and you get square root of 0, 0. Then you can hit square root again, put 0.5, and you get 0.707. And, oh, I messed up. It's 2 second square root of 0.5. That's 1.414. I forgot about the 2 there. Give it 2 second square root of 1. And you could have done that one in your head, probably square root of 1 is 1. The other way to do it is to just in the y equals menu, put in 2 square root of x, close the x like that. This way is actually much easier. Second window, give you table start, or table setup rather. These two, don't worry about those, but make sure independent's on ask and dependent is on auto. If you already changed that from a previous problem that we did together, then it'll just stay there. Hit second graph and goes to the table, and you could put in 0, 0.5, 1, 2, 3, 4, just that fast, and get your tables of values, okay? And then once you have your table of values, those are just your x and y coordinates. And you can see that the domain is x greater than or equal to 0, and the range is greater than or equal to 0. Notice that the graph is increasing on the entire domain. The minimum value is 0, and there's no symmetry. And we get that by plotting the points and drawing a smooth curve. Don't connect them with straight line segments. Make a nice curve that goes through those points. All right? Okay, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So the first one, we want to graph 4 square roots of x. So I would go to my y equals menu, change the 2 to a 4, graph, or second table rather, and here's my coordinates. So 0, 0, right here, and then 0.5, comma 282, so it'd be like right about there. And then 1, comma 4 is right about there. And then 2, 5.6. 2, 5 is right between 4 and 6. 5.6 would be like halfway again. So right there. 3 would go to almost 7. So that'd be right about there. 4 goes to 8. And let's do, what would 10 be? 10 would be 12.6. So right about there. And then we graph it with a smooth curve. And the domain is x. The domain would be x such that x is greater than or equal to 0. Again, the range would be x such, or y such that y is greater than or equal to 0. It's increasing on the entire domain, and the minimum is at 0, 0. It's the lowest point on the graph right there. Okay. If I wanted to do 6 square roots of x, I'd go back to my y equals menu, put in 6, enter second table, and then you get your points again. You'd have 0, 0, and then at 0.5 is at 4.2, so it's like right there. 2 is at 8.4, so that's like almost 8.5, which is there. 3 is at 10.3 right there. 4 is at 12, and then 10 is at 18.97, which would be right there. And then you see it just stretched it vertically more. Okay, and again, the domain for this one is x such that x is greater than or equal to 0. The range is y such that y is greater than or equal to 0. And it has a minimum at the origin, and it's increasing on its entire domain. Pretty cool, huh? All right, guys. Well, that's it for this section. Stay tuned for the next video.